we are going to continue working on integration and being able to find the antiderivative of different functions. And now we're going to take a look and see our constant term as well. So to begin with, we just talked about, hey, this is what the basic function would be, but now we're going to add that plus c, and we're going to actually learn how to find what that c value is in certain circumstances as well. So if f prime of x is f of x, so if the derivative of capital F of x is little f of x, then the integral, so then we can integrate little f of x dx, and that's just capital F of x plus that constant term. So in this function, if y equals x to the fourth plus 2x cubed, I want you to find the derivative of the function with respect to x. So be careful. Make sure you understand what the notation is saying. This is back before when we were just finding derivatives. So in this case, it's just saying find the derivative. Therefore, the derivative of this function, dy dx, is 4x cubed plus 6x squared. Because now that we're working on integration, it's really easy to forget how to take the derivative. So just be careful with that. So now, hence, we're going to integrate 2x cubed plus 3x squared with respect to x. So keeping that in mind, I did this above so you can kind of work backwards and see what did we do above that helped us take the derivative. So now that I have the derivative, how do I find my quote-unquote original function? So therefore, since I'm integrating this therefore equals, so I know I have to get an x to the fourth. However, in order to do that, I have to divide by 4. Plus, and then this has to be an x cubed. In order to get a cubed, I have to divide by 3. And there was a 3 in the top. And then there's plus c. So do not lose c. You cannot lose c. So then this just simplifies to a half x to the fourth plus x cubed plus c. Okay, so that's just integrating it, finding the antiderivative of our original function. So in differentiation, there's a whole bunch of rules. The derivative of constant is 0. The derivative of a linear function is just the coefficient of x. X to the n, we subtract 1 in the exponent, we drop it down. And then we have the product rule, quotient rule, chain rule, and then we have all these over here too. The natural log is 1 over x, don't forget that. The natural log of function is the derivative of the function over the original function. So there's lots of these different rules. Derivative of sine of x is cosine of x, derivative of cosine of x is the opposite of sine of x, etc. So a whole bunch of rules for differentiation. So you could pretty much take the derivative of most functions based on using these rules. That's not the case for integration. There aren't all these rules that work for all these cases. There's a few, and these are the few that we have. So if this is our original function, and we're taking the antiderivative of it, or we're finding the integral, going backwards, these are the few that we have. We've already worked, in essence, with these two, and a little bit with this one. Okay. But then we also have 1 over x. So when we anti-differentiate that, we get the natural log of x because the derivative of the natural log of x is 1 over x. And then cosine, because the derivative of sine of x is cosine of x. And then the antiderivative of sine of x is negative cosine of x. Kind of weird, because you know that the derivative of the cosine of x is the negative sine of x. And sometimes it helps to look at what they are initially. So again, I know that if my function is cosine of x, its derivative is the opposite of the sine of x. So being able to write them out forwards might help you going backwards. It just kind of depends. So don't forget, every single one of those is c, half plus c, and that's our constant of integration. So that's where there isn't a variable that's attached to it. And we will be able to solve for that constant. So we're going to just jump right into it, integrating the following functions just so that you can see a bunch of different examples of integrating. So for the first one, it's nicely set up. So therefore, we're integrating, so we're going backwards, which means this is x to the fourth. That means it's divided by 4. 2x, that has to go to the third, which means we have to divide by 3, plus 5. X to the first, divided by 1, and then plus c. Done. Second one, might want to rewrite it as x to the negative third minus x to the 1/2 dx. At least by rewriting it, it makes dropping that exponent, or in this case, increasing that exponent by 1 a little easier. So therefore, I add 1, so it's x to the negative second, but then I have to divide by negative 2. And then adding 1, so that's x to the 3/2. And then, so I have to divide by 3/2, which is the same thing as multiplying by 2/3, and it was already that subtraction sign, plus c. And you can just leave it just like that. If you wanted to, get rid of that negative exponent might be helpful. So this would be 1 over 2x squared, and that's the opposite of it. And then minus 2/3 x to the 3/2 power plus c. Okay, so just some pretty basic ones, just dealing with those exponents down. Next one starts looking at a few more differences. First one, we have sine and cosine. So to begin with, we're going to write this as the integration of 2 sine x minus cosine x, and that's with respect to x, so dx. So therefore, when I integrate this, the antiderivative of the sine of x is the negative cosine of x, so this is negative 2 cosine x. And then minus cosine x is antiderivative of cosine x is just sine x, because the derivative of sine x is cosine x. And then plus c. And then this one, this is the same thing as the integral of negative 2 times 1 over x plus 3 e to the x. And this is one of those. So if I have 1 over x, the antiderivative of 1 over x is the natural log of x. So therefore, this is negative 2 natural log of x plus 3 e to the x. The antiderivative of e to the x is e to the x plus c. If there was, remember that 2 up top there like we had in the other video, I'd have to divide down by that as well. Okay, onward to 2 more. There's no quotient rule, there's no product rule. So when you look at our rules, there aren't either of these. So we don't know how to undo the quotient rule. We don't know how to undo the product rule. I mean, look at this. When you took the derivative, the quotient rule, can you imagine trying to undo that to get this? Now sometimes, hey, maybe you can see it. That would be pretty tough. Product rule is the same way because we're multiplying those pieces together. We're squaring different functions. So it's a really hard thing to see. Therefore, we anticipate we can't do it that way. So we must be able to rewrite these functions so that I can integrate them. Or maybe we're going to learn later on, we can do a unique type of substitution to give us that ability to do it. So therefore, from the very beginning, rewrite. So it says this whole quantity squared. Okay, so let's do that. So we're going to integrate. So it says the whole thing squared, which means that's 9x squared. Remember, this is 2x to the negative first. So therefore, when I multiply them together, I get 3x times 2x to the negative first, which is 6x to the 0. And when I double that, that's 12. And then 2x to the negative first times 2x to the negative first is 4x to the negative second. And then that's dx. Okay? Now I can integrate all of those terms. So this is equivalent to, so x to the third, so 9, and I have to divide that by 3, plus 12x plus 4x to the negative first over negative 1 plus c, which then just simplifies to 3x cubed plus 12x minus 4 over x, getting rid of the negative exponent, plus c. So this here simplified to this when I integrated it. Now with the second one, it looks kind of like the quotient rule, but actually I can rewrite it because it's all being divided by the square root of x. So that is equivalent to x squared over x to the 1/2 minus 2 over x to the 1/2 with respect to x. So therefore, I'm going to integrate x to the 3/2 minus 2x to the -1/2 dx. The more you can simplify ahead of time, the easier it makes it, and it's the only way you can do it. So therefore, now when I anti-differentiate this, I get, so add 1, x to the 5/2, and then multiply that by 2/5. Dividing by 5/2 is the same thing as multiplying by 2/5. Minus 2x to the 1/2. Dividing by 1/2 is the same thing as multiplying by 2. Plus c. So that's equivalent to 2/5 x to the 5/2. And then 2 times 2 is 4, so minus 4. X to the 1/2 or the square root of x, it doesn't matter. Plus c. Good. So this is just different types of practice problems, just getting you to integrate. Just be aware, though, again, if you see something where it looks like a product rule, quotient rule, chain rule, etc., like rewrite it. See what you can do with it so that you can actually take the antiderivative of it. So the last part is, all of these have plus c's, plus c, plus c, plus c. How do we solve for that plus c? So I'm trying to figure out what is my function. That's the antiderivative of each of these. In order to find it, we need a coordinate point. We need a physical point. So in this example, I'm telling you to find f of x given the derivative. So I know I'm going to integrate this. And then I have a coordinate point, which helps me find any other point. So we're going to have an unknown. I mean, think about this. Whenever you have a function and you're trying to find an unknown, you plug in a point to solve for your last unknown. That's what we're going to do here, is we have to have a point. It doesn't matter what point it is. Okay, in this case, it just so happens to be my y-intercept. But it can be any point along the way to help me find that c value. So, starting off, I need to figure out what f of x is. So, since I have my original function, I then know that f of x equals x to the 4th over 4 minus 2x to the 3rd over 3 plus 3x plus constant term. So all I have to do is plug in that coordinate point. 0 is my x, 2 is my f of x, and solve and get c. So 2 equals 0 minus 0 plus 0 plus c. Okay, so when you have your y-intercept, it definitely makes it a lot easier. So therefore, you know c is 2. Since you know c is 2, you now can write your equation for f of x. So that is 1/4 x to the 4th minus 2/3 x cubed plus 3x plus 2. So there's your equation based on that point. The last example, same thing. Different coordinate point, different situation. I also gave you the y-intercept in this case, not quite as helpful, but still definitely doable. So I have to differentiate this. Therefore, to find f of x, I'm just going to write this out in words. I have to integrate 2 sine of x minus, and I'm going to write this out as x to the 1/2, and then that's dx. Okay, so it's showing all my work. So therefore, f of x is, so the derivative, or the antiderivative of sine x is negative cosine x. So this is negative 2 cosine x minus x to the 3/2 times 2/3 plus c. Now I plug in my coordinate point for y, 0 for x. So 4 equals negative 2 times the cosine of 0 minus, that's 0, plus c. So, unit circle, cosine of 0, so here's 0 radians, 0 degrees, either one. So the cosine of this, cosine being your x value, that's 1. So 4 equals 2 times 1 plus c. Oh, that's a negative 2. Add the 2 over to the other side, so c therefore is 6. Therefore, my final answer for this, f of x equals -2 times the cosine of x minus 2/3 x to the 3/2 power plus 6. So now you should be able to anti-differentiate more different types of situations. Don't forget to put that c there. If they give you a coordinate point that it goes through, or you can find a coordinate point it goes through, substitute that point in and find that last unknown, find that constant term. Okay, and we're going to learn a little bit more of integration techniques, but this should give you a good start to practice.